Welcome, curious minds, to The Deep Dive. Today, we're stepping back, way back into Victorian Britain. It's a time of incredible change. The landscape itself is being reshaped.
Absolutely. Not by magic, but by sheer industrial power. Iron, steam, relentless innovation. It was the heart of the Industrial Revolution.
Exactly. And they weren't just tweaking things, they were fundamentally rewriting what possible even meant. Engineering giants walking the earth, almost literally.
And right there at the very center of it all, you have this one name that just echoes. Isambard Kingdom Brunel. Monumental achievements, incredible vision.
He wasn't just a builder, was he? He was the builder. Driven by this need, this almost obsession to build bigger, faster, better.
Yeah, he really shaped the nation, connecting cities, bridging rivers, things people hadn't even dreamed of before. And for this deep dive, we're leaning heavily on L.T.C. Rolt's classic biography. It gives such a great insight into the man, his character, and of course, his incredible work.
Right. So our mission today, we want to get under the skin of Brunel's genius, explore that fearless innovation, the almost obsessive detail, the tireless project management, all the stuff that made him the archetype of the heroic engineer.
And for you listening, the question is, what can we learn from him? About tackling huge challenges, about embracing new stuff, new materials, leading these incredibly complex projects, lessons that, still apply today.
Definitely. So let's get into it. Okay, first off, the man himself, Brunel. You kind of picture this titan of industry loving the spotlight, right? Presenting his grand plans.
You would think so, but Rolt's biography paints a very different picture, almost contradictory, really. Hashtag tag tag taggy, the reluctant public figure and astute strategist.
Yeah, it's fascinating. His personal feelings about, public speaking, committee meetings, he absolutely dreaded them. He actually said he saw them as playing with a tiger, and all you can hope is that you may not get scratched or worse. Wow. Playing with a tiger, that's intense. It tells you so much about the pressure he felt, the unpredictability of it all from his perspective. He was a doer, not a talker, fundamentally.
Exactly. But here's the thing. Despite hating it, he knew it was necessary. He got the strategy part. Like Rolt mentions that time he warned the Bristol Committee, basically told them, don't spill the beans in London too early.
Right. Hold your cards close.
And they listened. It shows he had this strategic nous right from the start, managing those crucial relationships, knowing when to push, when to hold back. It wasn't just about the engineering drawings.
That really connects to modern project management, doesn't it?
Yeah.
That whole idea of tailoring based on context.
Absolutely. That's straight out of the PMBOK, the project management body of knowledge, adapting your approach based on, the specific goals, the stakeholders, the whole environment. Brunel was doing that instinctively. He knew launching the idea prematurely in London could kill it, no matter how good the engineering was. It's so smart. It wasn't just nuts and bolts. It was people and politics, too. And speaking of the long game, his vision required incredible endurance, like that trip to London, August 15th, by coach, then the meeting on the 22nd.
Yeah. And Rolt notes his initial impatience. You can just feel him fidgeting through the endless talk of committees he wanted to be building.
But then Rolt adds that amazing line that Brunel was to recover that lost virtue of patience, perforce, however, by the time the new railway was established. He learned it because he had to, agonizingly probably.
It really makes you think, doesn't it? For leaders today, how do you balance that fire, that passion to get things done now, with the, let's face it, often grindingly slow process of getting everyone on board, navigating the politics?
It's tough. That's where emotional intelligence comes in, right? Staying calm, staying focused, even when things feel stalled.
Exactly. It takes more than just a great idea. It takes that gritty persistence, that willingness to endure the endless talk to actually make the vision real. Patience isn't passive. It's strategic waiting, strategic maneuvering. Okay, so from strategic patience to sheer, bold-faced audacity. Brunel wasn't afraid to go way off-piste, was he? Let's talk about the atmospheric railway.
Yes. The project that often gets labeled a folly or a fantastic mechanical joke in hindsight.
Easy to say now. But Rolt rightly points out, it is notoriously easy to be wise after the event.
So true. You have to put yourself back then. The promise of the atmospheric system was revolutionary. Imagine being told you could be borne along by the powers of the air so smoothly, swiftly, and silently.
Wow. Compared to the noisy, dirty steam trains of the day.
Exactly.
Hmm?
To accelerate so rapidly and with such a complete absence of any apparent effort, it sounded almost magical, like frictionless travel, a total leap into the future.
And not just speed and comfort, but safety, too. That was a huge part of it, wasn't it?
A massive part. The system inherently created an absolute block. Basically, only one train could be in a section at a time, which meant entirely new standards of safety and high-speed travel.
And that absolute block idea eventually became standard railway practice.
Yeah.
Much later.
Decades later, yes. So Brunel was way ahead of the curve on safety. He saw what railways could be, not just what they were.
It really speaks to his character. Rolt says something like, of all the engineers in the country, Brunel was by temperament and character the most likely to accept that challenge with both hands.
Yeah, he just grabbed it. It fits that idea of creativity being knowing what to do when the rules run out or there are no rules in the first place. He saw this completely new concept, no rule book existed, and he just dove in.
And he cared about how it looked, too. Even the functional bits, the engine houses for the atmospheric railway's vacuum pumps. He didn't just build sheds.
No, he took great pains with their design. Italianate style on his South Devon line, Gothic for another line. He wanted them to fit in to not disfigure their setting.
That's amazing. He was introducing these symbols of the new industrial age, but trying to do it thoughtfully, integrating them into landscapes that hadn't changed for centuries.
Which raises a really interesting question for us looking back. How should we judge innovations that don't quite make it? Was the atmospheric railway brave pioneering, or was it, just ignoring reality?
It's tricky. Maybe the idea was brilliant, but the tech just wasn't quite there yet. The leather seals for the vacuum pipe famously had problems, didn't they? Rats chewing them.
Yeah, practical nightmares. But the core concept, safe, smooth, atmospheric power parts of that vision were spot on. It shows that sometimes failure is just a stepping stone. And his attention to aesthetics reminds us that great engineering can, and maybe should, be beautiful too. It's not just about function.
Okay, so from atmospheric dreams, let's get grounded, literally. We need to talk about the massive projects that really cemented his legacy. The railways, the bridges. This is where he becomes the true master of iron.
Right. And it starts beneath the surface, doesn't it, with the unseen work. When you look at something like the Great Western Railway or Clifton Suspension Bridge or even the Thames Tunnel, you see the arches, the towers, the ironwork. But the real battle, the initial huge effort, was often underground.
Yeah.
The foundations.
Absolutely. Unsung heroes. For the GWR, cutting through hills, spanning valleys, the ground conditions must have been incredibly challenging. Same for the bridge anchorages.
Totally variable, often treacherous. And while we don't have, detailed specs for every single concrete pour, we can look at the best practices of the time, which Brunel would have been pushing to the absolute limit.
Like using concrete with Portland cement for footings. Kidder Parker mentions it needing to be, at least 8 inches thick, maybe 12 or more for big structures.
Easily 12 inches, probably much more in places for Brunel's work. Trenches dug precisely, or using planks if the soil was loose. And then letting it cure, harden, for days.
And that curing process, that's crucial, isn't it? It's not just about drying.
Not at all. Concrete gains strength over time, especially if kept moist. We know now that moist-cured concrete is still gaining strength after 6 months. Air-dried concrete just stops.
Imagine trying to manage that outdoors, in all weathers, without modern tech. Hot weather making it cure too fast.
A constant battle. They might have used cool ingredients, maybe even crushed ice sometimes, just trying to control that chemical reaction. Brunel's famous attention to detail would have absolutely extended down to the mud and the cement mix.
And concrete alone wasn't always enough, right? Especially under tension, being pulled apart.
Exactly. That's where reinforcement comes in. Steel bars or maybe welded wire fabric later on embedded in the concrete to give it that tensile strength. Stone and concrete are great under compression, being squeezed, but terrible under tension.
So for bridges, arches, tunnel linings, anything subject to pulling or bending forces, that reinforcement was key. Think about the Clifton Suspension Bridge. The sheer pull of those chains had to be anchored deep into the rock. Massive forces.
And it wasn't just concrete. Masonry was vital. Those huge viaducts, retaining walls, techniques like grouted masonry, filling all the inside joints with grout, basically cement mortar to make it one solid, strong mass.
He was using the best stuff available, materials like septeria, that clay, for making Parker's Roman cement, before Portland cement really dominated. He was right at the cutting edge of material science for his day.
And you have to put it in historical context. Think about how the Romans built on a massive scale, using lots of manpower, small materials like bricks, and concrete. Very different from, say, the intricate stonework of the Greeks.
Right. Brunel inherited that challenge of scale, but tackled it with new industrial materials and a new level of engineering precision. Maybe the ultimate example of this foundational challenge was the Thames Tunnel.
Oh, absolutely. The first tunnel under a navigable river, constant flooding, shifting ground, lethal gas, it nearly killed him. Just driving that shield forward, holding back the river and the earth. An unbelievable feat of foundation engineering and sheer grit.
Okay, let's talk iron. The defining material of his career, really. He didn't just use it. He made it do things nobody thought possible.
It's amazing how revolutionary it was, especially given the architectural establishment's view at the time.
Yeah, John Ruskin, massively influential critic, basically saying in the Seven Lamps of Architecture that iron is not a proper material for architecture, full stop, except maybe for some mythical temple.
Right. He saw it as crude, industrial, lacking the nobility of stone. So Brunel wasn't just overcoming technical hurdles, he was fighting against deeply ingrained aesthetic prejudice.
But he pushed on, demanding incredible precision. Even early books on metalwork, like Moxon's, stress the meticulousness needed preparing the plates, soldering, filing, getting everything perfectly flat and hard.
And Brunel needed that same level of care, but on a vastly bigger scale. For the chains of the Clifton Bridge, the riveted plates of his ship's hulls, pushing industrial fabrication to its limits, demanding near craftsman quality on monumental structures.
It's a huge leap from small metalwork to, say, the roof for Paddington Station or the Saltash Bridge, isn't it?
Yeah.
But that need for precision is the same.
And structurally, iron was the game changer. We know stone is bad intention, right? It cracks if you pull it. Iron, especially wrought iron, had much better tensile strength.
Meaning you could span bigger gaps, build lighter, more elegant structures.
Exactly. Suddenly, engineers had options they never had with stone alone. But it brought new challenges, too, understanding how iron behaves under load, how to design joints, how to prevent corrosion, how to fabricate these huge components reliably.
Brunel wasn't just using iron, he sort of understood it. He spoke its language.
That's a great way to put it. He became its champion. Which makes you wonder, how do pioneers get new, maybe controversial materials accepted? How do you become a true master of a material like he did?
He didn't just use it, he showed everyone what it could do. His bridges, his ships, they weren't just functional, they were often breathtakingly elegant. He proved Ruskin wrong. In steel, well, in iron.
So, having conquered land with railways and bridges, Brunel inevitably turned his sights to the sea. And again, he wasn't thinking small. He aimed to revolutionize ocean travel.
Starting with the SS Great Western, a real game changer.
Absolutely. It was a direct challenge to sail power for long voyages. Rolt describes the launch in Bristol, July 1837. It wasn't just slipping a boat into the water, it was a massive public event, a ceremonial lunch for 300 people.
300 before the engines were even in. That tells you the level of excitement, the national pride already invested in this thing.
Definitely. Then she sailed to London to get her engines fitted, saloon decorated, building even more anticipation and the public reaction. Rolt says crowds flocked down to the river to admire her magnificent proportions and stupendous machinery.
You have to imagine seeing this massive wooden paddle steamer built for the Atlantic crossing. It must look like something from the future, pure awe.
And the look of her. Rolt mentions the somber black hull, but with that gilded figure of Neptune escorted by 2 dolphins at the bow. That mix of serious engineering and artistic flair.
Classic Brunel. Functional, but also aiming for grandeur. It's a shame no pictures of the Grand Saloon survived, apparently. Adds to the mystique.
It does, but it highlights how these big projects capture the public imagination. They become symbols. It's not just about getting from A to B. It's about national prestige, technological prowess.
The Great Western proved transatlantic steam was viable. And that just paved the way for, well, for even bigger things.
If the Great Western was the proof of concept, and the SS Great Britain first big iron-hulled, propeller-driven ship was the next leap, then the SS Great Eastern was just off the scale. It became Brunel's ultimate obsession, his defining struggle.
Rolt calls it a latter-day Tower of Babel, doesn't he? Plagued by problems, human fallibility, and folly.
Absolutely dogged by misfortune, technical challenges, financial nightmares even, as Rolt puts it, the envy and the malice of lesser men. Brunel poured everything into it and faced immense opposition and difficulty.
But his core philosophy, right? No retreat, no acknowledgement of defeat.
That was pure Brunel. It wasn't just a saying, it was how he operated. When things looked impossible, when creditors were circling, when construction ground to a halt, he didn't back down.
He stepped in personally, didn't he? After weeks and arguments, got an agreement, and took over direct supervision.
He did, which in modern terms is like extreme crisis management, handling claims, pushing through change orders under immense pressure. It's that adaptability, that resilience the project management books talk about, but lived out in the most dramatic way possible, sheer force of will keeping it alive.
And the ship itself, technically, it was just astounding, that decision to use both screw propellers and paddle wheels.
Unheard of, but necessary. Brunel calculated that no single propeller or paddle shaft technology at the time could deliver enough power to drive a ship that enormous at the speeds needed.
So he combined them, hedging his bets or just doubling down.
More like creating a hybrid solution out of necessity. He needed immense power. And he learned from past projects, too. He wanted a direct drive for the propeller shaft, avoiding the troublesome chain drive he'd used on the Great Britain.
So constant iteration, constant learning. Do we know the power figures?
We do. The screw engines aim for 4,000 indicated horsepower. The paddles, 2,600. Huge numbers for the day. Both running on relatively low-pressure steam, about 15 psi. The propeller itself was massive, 24 feet across.
And he had practical constraints driving the design too, right? Like the depth of rivers it needed to use.
Exactly. The Hooghly River in India was key, limiting the draft to 30 feet. He did incredibly detailed calculations about coal, cargo, draft. The paddles were actually designed partly to help when the ship was riding higher in the water, say at 22 feet draft, because the propeller would be partially exposed.
Wow. So the two systems work together dynamically.
Precisely. It was a complex, integrated system figured out after long talks with Joshua Field's company. The paddle wheels themselves were enormous, 60 feet in diameter, designed to have 6 feet submerged even at a 20-foot draft. Just mind-boggling scale.
But the biggest challenge wasn't even building it or the engines.
Uh-huh.
It was getting it into the water.
That's what Brunel believed. Floating it. He thought that was by far the most difficult and hazardous part of the whole operation. Much riskier than a conventional launch down slipways.
Right, because of the size and the location?
Exactly. Floating so large a ship in so narrow and shallow a river, the Thames at Millwall, where there was literally not an inch to spare, it demanded unbelievable precision.
How precise?
The hull had to be trimmed perfectly, floating at an exact draft fore and aft and on a completely even keel. And this trim couldn't be tested. It had to be determined purely by calculation.
Talk about pressure. And that's when his assistant messed up. Didn't give him the figures.
Yeah, Scott Russell apparently neglected to give him the necessary data. Crucial details about centers of gravity, weight distribution. You can imagine Brunel's anxiety. A miscalculation, a missing number could spell disaster.
And even if the calculations were perfect, there were still things outside his control.
Totally. The unpredictable vagaries of wind, weather, and tide. It's a perfect storm of risk management challenges. Meticulous planning bumping up against pure chance and human error.
Yet, even after setbacks, like funding falling through right before the launch, he kept going. That last act Rolt mentions, arranging passes for his railway workers to see the ship, that's incredibly poignant.
It really is. Utter dedication right to the very end. Which leaves us with that question. What does it take? That level of focus against such huge odds. How much is planning? How much is sheer will? Brunel embodied that no-retreat idea perhaps more than anyone.
So looking at everything, Brunel really does become this archetype, doesn't he? More than just an engineer, a symbol of something bigger.
Absolutely. His life and work just scream engineering geniuses and leadership, lessons that are still so relevant, #A. The traits of engineering genius and leadership, even when things were toughest, the Great Eastern struggles. His own health failing Rolt makes the point that his engineering genius and judgment remained sharp, especially during the incredibly risky floating operation. That clarity under extreme pressure, that's a hallmark of exceptional leaders.
It really is. And you can see those modern leadership behaviors like the ones in the PMBOK just shining through, motivating people, influencing committees, directing huge teams.
And that self-awareness, self-management, staying calm, or at least appearing calm and staying productive when everything's going wrong. He must have mastered that, faced it so many times.
And that idea of contextual tailoring we talked about, that was his signature move, never a cookie-cutter approach.
Never. Whether it was designing engine houses to fit the landscape, choosing materials for a bridge, or inventing a whole new propulsion system because the context demanded it, he was always adapting. A bespoke solution for every unique problem.
It comes back to that creativity idea, knowing what to do when the rules run out. He spent his whole career operating outside the existing rulebook.
He did, but, and this is crucial, it wasn't just wild dreaming. Engineering demands logic and precision, as Samuel Foreman wrote. Brunel's daring was always backed up by rigorous calculation, meticulous analysis. He made the dreams work through sheer intellectual horsepower.
The dreamer and the pragmatist combined. Hashtag BB, the precursor to modern project management.
And looking back, his whole approach feels incredibly modern in terms of project management. He was so hands-on, involved in everything from the initial strategy right through to crisis intervention.
Yeah, way beyond just delivering the technical plans.
Think about time management, his battles with committees, learning patience the hard way. It underlines how critical scheduling and managing timelines are, something the construction management standards emphasize today.
Definitely. Cost and risk. You don't have the spreadsheets, but the stories, especially around the Great Eastern, the Tower of Babel comment, scream massive cost overruns and risks.
Right, which highlights the need for identifying risks early, having mitigation strategies. Brunel's no-defeat attitude was almost a personal risk mitigation strategy in itself. It kept things moving against the odds.
And how did he keep it all straight? These vast, complex projects. Today we have BIM, building information modeling, 3D models, scheduling, cost control, all integrated digitally.
Exactly, virtual construction. Brunel did that in his head. And through incredibly detailed drawings and constant supervision, he had this integrated mental model of the entire system. As the architect Louis Sullivan might say, he had the power to create beneficently, to see the whole thing before it existed.
Which leads us to his ultimate legacy. He wasn't just building things, he was inspiring people. He embodies that creative dreamer idea Louis Sullivan wrote about.
Oh, absolutely. Sullivan admired engineers who did dare to think, dare to have faith, dare to do, men who could imagine things and then harness science to make them real. That's Brunel to a T.
And the impact wasn't just technical, it was societal. He literally changed the face of his nation.
Profoundly. Connecting Britain, speeding up travel and communication, enabling trade. It ties into modern ideas of social responsibility, that leaders and their creations have impacts far beyond the bottom line. Brunel shaped Britain's future.
And he did it by thinking in systems, didn't he? Seeing how everything connected, the geology, the materials, the finances, the people, the rivers, the oceans.
Yes, that holistic view. Understanding the interconnections, the feedback loops, looking at the long-term structure. He wasn't just solving problem A, then problem B. He was designing whole systems, railway systems, shipping systems that had resilience and logic built in. A true visionary. #outro.
So as we wrap up this deep dive, Isambard Kingdom Brunel, just an incredible figure, truly the master of iron, fusing that hard-nosed engineering precision with, well, an almost artistic audacity.
His career was just one landmark after another. The strategic fights for the Great Western Railway, the bold experiment of the atmospheric railway, the sheer perseverance of the Thames Tunnel, the world-changing ships like the Great Britain and the Great Eastern. He just kept pushing the boundaries.
And the lessons for us today are huge, aren't they? Fearless innovation, meticulous planning, but also that sheer, stubborn perseverance when things get tough, facing down those unpredictable vagaries.
It's that resilience, that belief in the vision. It's timeless. True pioneering takes guts as well as genius.
Which leaves us with a final thought for you, our listener. In our world today, so optimized, so data-driven, with amazing tools like BIM, how do we keep that spirit of the creative dreamer, Brunel's spirit, alive?
Yeah, what's the balance now between methodical planning, following the process, and that sheer individual will to make the impossible happen, especially when the data might say stop or retreat?
How much unpredictability can our models really capture? And what role does that individual spark, that relentless vision, and maybe even that no-retreat attitude still play in shaping what comes next?
Brunel's story kind of reminds us, doesn't it, that sometimes the human spirit, dreaming big, refusing to quit, might just be the most powerful engineering tool we have.